Oh, did the stream ended?
Oh.
Did the stream? Oh.
Yeah. Oh no, it's here. Refresh.
Refresh.
Yeah.
Oh, okay. What the heck?
Yeah, it froze for me too. I'm not sure.
Okay. My end it just ended for no apparent reason, but
Awesome.
that was weird.
Yeah.
Okay, I need to make sure if it's still streaming. Okay, we are still live. Okay. All right.
Oh, very nice.
So we have live stream from there, so everything will be on YouTube, obviously. And yeah, and we can show the next slide. Yeah. So what is Integration Bee? Who doesn't know here what Integration Bee is? Like, please raise your hands. Okay, so everybody knows. No, I know this one. No, I will explain that. Okay, our dear sponsors, without whom that wouldn't be possible. First of all, University of Vienna. We have the room, we have new people here, we have the community, we have support. Thank you, University of Vienna, for this cool opportunity to be organized. So please round of applause to the University of Vienna. Now, RD Mate. Currently, they are having Chisliak somewhere there for the evening. So there, I can't see anybody from the over here. So we are very grateful for them. They are really responsible for the drinks and the snacks that we have there, absolutely for free. You can enjoy them at any time. Yeah, they gave us lots of support, lots of help. So also, loud round of applause to them. So that's really good company from our perspective, because they are friends of ours. They help us supporting this event with something that we will show at the end, and also with some technical support as well, streaming as well. Yeah, they're mostly doing IoT solutions. They are doing robotic and optimization stuff, and I know that some people actually in this room and in the room yesterday actually are interested in this stuff. So they are always open to work with smart, interesting people. Yeah, always reach out. They are cool. They're one of our good sponsors. So please round of applause to the Gamma. Formaman, guys, are responsible for our web platform, for our new game that we have on the platform, the integral of the day, so integration gym that you can solve basically every day. They are doing platforms, software platforms like CRM, ERP systems, or organization systems. They are mostly focused on AI and cloud solutions. And yeah, so they are also very important, and this event wouldn't probably be happening without them. So round of applause. And Smarties, also a company that does, a Viennese company actually from Vienna. Other companies were from some other parts of the world, and this is actually a company from Vienna that is responsible for our main prize. And yeah, I think they are making this event actually the most memorable for the winner of the event, because he will receive the prize. Yeah. So what they are doing consulting, accounting, IT solutions, and many more. They are actually lots of stuff that they are doing. Also, they are always open to work with smart people who always reach out. We're here in Vienna, they always go. Yeah, round of applause to our Next of our organizers, those are the people who can reach out at any point. Most of them you can see here on the stage. Some of them are more behind the scenes. So obviously me on the very top, it's me, Max. Then Sam, who is sitting there, who has presented basically everything yesterday. Then Konsti, where are you? Are you here? Yes, sir. Oh my god. Okay. Bachelor seminar. Okay, that is important. So, Konsti is here, Konsti Podajka. Adrian Weisswendel, also you can see him here. He started as a competitor, then he became a program writer, and now he is like one of the most important core parts of the team. Next slide, please. And it's Spiridonov, the guy who comes a bit later, because he's bringing some stuff, including the tripod for the stream and the main prize. Moisey Plistiev, who is also responsible for the streaming, he is there, and he is also provided a huge help in actually organizing the event and talking to people. And our newest member, Cao Suo, and the youngest member, Cao Suo, who also started as a competitor last time, and then he joined our integral writing team, and now he is helping us here. So also a round of applause to Cao Suo. And more team members. Jonas, who was not present yesterday, but now he's finally here and here. We're happy to see him here. He's there, our dear photographer, and you can see his professional picture right there. Jonas Kaczykowski. Yeah, and we're really happy to see him today. Lukas Rakimas, person who was probably the first person to reach us out and start writing integrals for us, and he has come up with lots of great integrals and has helped us with lots of things like connections and organization stuff. And two people who are present there or will virtually, because if you go on the live stream on YouTube, that is happening right now, you can see those two people, Silver and Evan Kniffen, as live commenters to the stream. So if you actually at any point want to find out what's happening here because you don't understand anything in the room, or if you just want to have more fun by listening to what's happening, go on the stream and listen to those two guys commenting live. So, and Silver is actually a very popular integral YouTuber, and he recently made his own book about integrals with like very interesting integral problems. You can buy it on Amazon and get it delivered to Austria like very easily. It's just something I wanted to share because he helped us a lot, and probably he's going to help us with Integration Bee, who knows. So yeah, his book with integrals is something. Yeah, special thanks to one of the most important persons in this organization is Teresa Eisenberger. Please round of applause. Teresa is a part of the Dean office. She guided us through the ways of university. She showed us how to do the events at the university. She supported us all the way, and without her, this event wouldn't be possible, like absolutely at all. So yeah, this is one of the most important organizations in this event. Now, Fedorina, the person who we can see there, the person who is always helping us with lots of different stuff. And today he is responsible for drinks and foods that you can see there. So if you have any questions about that, what's gluten free, what's not, or something, you can reach out to him. He's always welcome. And he's a very nice and friendly guy, don't be shy. And the person who I added to this list just right now is Daria Polutina, who is a girl who was actually not planned to be actually involved in the event. But today she has been like lots of help with something that I'm trying not to spoil. It's also a surprise for the leader. Yeah, with some artistic help. And also a round of applause to those two people. So, what is memorable about 6th of June? Yesterday we said about Joe Adam being born. What's memorable about 6th of June? 62 years since the death of Giulio Bobini. And fun fact, Bobini, a theorem of Bobini, is used a few times in few integrals during this competition. And fortunately, this guy is for 62 years not with us anymore, but he has contributed greatly to the adult community in general. And there is also 168 years since the birth of Alexander Latino, which, as the many people here I think know, also contributing greatly to mathematics and variance. And 118 years since the birth of Max Thorn, who we know from Thorn lemma, and actually he things as well. Okay, rules and structure. Here I really want to give the word to Sam because he orients here much better than I do.
Don't cheat.
That was basically the entire rules that we need to follow. We also have a bit more extended rules, but competitors already know them from day one, so there is no reason to do. So summary of day one, we had here some interesting matches. On the 8 finals, we had the entire 8 finals done, and we had some on the quarterfinals. And here happened some problem because was he? I don't know. I won't know his first name, but the guy whose surname is Bertishu. Anton, yeah. Okay. Anton Bertishu. He unfortunately quit, and we had to replace him with another guy who just registered. Also, round of applause to. Yeah. So this is the table how it will happen now. Yesterday we didn't have time to actually have the last quarterfinal. This is the stuff that we start with. That we will do against Kemper. And after that we'll start with semifinals, which is one of the greatest part of the event. Also, one thing that we made very before the event, if you go right now on our Instagram, on our stories, there is a link to the poll when you can vote and predict who is the winner today. So it would be actually very great if all of you go there on that link and vote, and we can see right at the beginning of semifinals who is going to win according to the public. Okay, so next slide. So this is the tournament table once again. So this is what's happening on the.
No, it's not.
What?
Not from this year.
What?
It's a wrong picture. Just
Okay.
open the game.
Okay, so if you want to have correct picture, go on the website. On the website, and there is a correct live updated bracket. Okay, and at this point, I think I have said everything that has to be said, and let the game begin. So.
All right. Thank you, Maxime.
We start with the last quarterfinal, and Gavin Flugel and what was your first name? Borsha. Cooper are invited to the board.
All right. To our just our
last round of quarterfinals here.
yeah. Our 2 last quarterfinalists.
And it looks like we finally got 2 boards today, which is nice.
Oh, I just noticed that actually. Yeah, this is a different room.
Yeah. We ended up moving to a large after yesterday with having to draw the board different.
Okay.
Oh,
Well, we can't. There we go.
Ooh.
Okay. 0. I'm not sure. From 0 to 1, x over e to the x plus e to the 1 minus x? Oh, okay.
Yeah.
This seems like something that we would use for King's rule.
Yeah, almost assuredly.
Yeah. Oh. It's not even on the PDF. I don't think this problem's on the PDF.
What? It doesn't exist.
It's okay. But yeah, usually I have another tab to showcase the problems, but we cannot find it on the PDF.
That's funny.
Surprisingly. Page 10. Oh, I have it right here. It's in page 10. Yeah.
Holy moly. It doesn't seem like either of them are going for the King's Rule approach, which worries me for how they're going to end up with a solution to this one.
Yeah, one of them's using u equals e to the x. Whoa, we've been dropped. Okay.
There we go.
But but u equals e to the x. I mean, I guess one way to do. I was thinking about using geometric series. If you're going to use u equal e to the x, you could do geometric series. But you have that plus e.
Yeah, I think you'd end up. Ooh, yeah, I'm not sure what they're ended up doing here. They could do integration by parts from this log they've got up top.
Mm-hmm.
Oh, and I think they might be both in the same spot.
ln of u squared plus e. From 1 over e to e. Oh no, that's from 1 to e. Okay, I thought that lower bound was 1 over e. If that was you could, that would be a nice inversion, but
yeah,
no, that won't work.
Interesting.
Wow.
I think here the only way to get out of this without using King's rule would be, because I do not think this would have a elementary antiderivative, so
No, I don't think so.
it worries me for how we'll get out of this one.
Wow. One's doing integration by parts, one's doing full-on u sub. We have 1 minute remaining.
Oh man.
Yeah.
It looked like, so on the right they did u is equal to 1/2 minus x to try to see if they can do some sort of odd and even trick.
Oh, okay.
This might work if they notice that they end up with a 1/2 minus x up top.
Yeah.
That might give them some ideas here.
But will they notice it in a short amount of time? Oh, plus C? Wait, the board on the left?
Wait, what happened?
I don't know. Huh.
Well,
Wait, that's
it's
should be definite.
He didn't. Yeah. Oh, they ran at its time.
Okay.
Wow, on the right they were so close. They ended up getting it into where they could reduce it by using odd and even, which is very interesting.
Yeah.
So on the right, they definitely had it. If they had more time, it seems like they would have been able to get it done. They were really right there.
Yeah. Oh, so close.
So close. Unfortunate.
Yeah. But anyways.
I wonder how he got that antiderivative.
Yeah, I was wondering too, because I thought it wouldn't be elementary. Well, this is what we have. Yeah. And usually the fastest way is to use King's rule. But yeah. Very close though. The symmetry could actually lead to it. But for the next integral now, we have, I cannot see. I can't tell if it's the, okay, so it is the one that we have here. So I'm gonna slowly scroll. It is this integral here. We have from -infinity to infinity, and God, the absolute value. Does this even converge?
I did not write this one, so I will not make assumptions as to it should converge. It'd be.
Oh wait. Oh no, wait. I mean, if this was the case, the only thing I could think about is that in order for this to converge, the integral must equal to 0. But
Yeah,
I could be wrong though.
I mean, I thought wild if it wasn't.
That's
Yeah, I
crazy.
think graphing is the way to go here.
Wow. I don't know how the absolute value is gonna make it converge. I just can't see it.
No, me either.
X squared minus 7x plus 10.
Yeah,
Wait.
I don't know. I also have a hard time. If this converges, I'm wildly impressed with the person who wrote this.
Yeah. Wait, they ended up with a different bound. Wait, from 2 to 5.
Yeah, it looks like they're trying to just do the integral of the absolute value of.
Oh, okay.
Uh-huh. Because everything else will cancel out, I guess.
Will that really work? Will it actually cancel each other out?
I guess it. If you take it as two separate integrals, the positive components will both cancel out, and then you
Oh, okay.
times the integral from 2 to 5. Wow, that's a neat trick.
Holy hell.
Wow. Okay, well then the guy on the right here, I think, is
Got the right idea. Or yeah, is
he's
about
definitely
to.
the right idea. He's so close. He's right there. Because I think that's all you need to do is just do 2 times 5.
Yeah.
And you're there. Wow. That's a really cool integral. I like that a lot.
1 minute remaining. So that's a good enough time to like check all the work and stuff.
Oh, for sure. Yeah. With a 1 minute left.
Mm-hmm. Yeah, I think he's just making sure everything's calculated correctly.
Yeah, I think he realized that everything else goes to 0 with his problem on the right. I am really hoping he remembers the 2 in there.
Oh, nice. I think he caught it.
Yeah.
Oh, 10 seconds. Oh my god. Come on.
He's ready to go down.
Honestly, I would have done the same thing.
Oh no, we're gonna be in simplification hell. Oh gosh.
Yeah, I think they're gonna work on it right now.
Yeah. That's a really cool integral. I really
Yeah, no,
like
that's
that.
crazy. I would not think that would actually converge.
No,
I would have
never
never
in all my
imagined.
years. Never in all my years of integrating, I would have expected this to converge.
Yeah.
It is very, very cool. I like that a lot.
Oh, we are being carried.
It looks like they're trying to.
Yeah, they're just judging. They're just trying to simplify right now. But
Not sure where we're going.
oh, we're just trying to scoot farther back so that I think trying to get a better view. But it'll just be a little bit more farther away.
Oh. I hope nothing's on screen right now.
Yeah.
Oh, we're drifting.
Okay.
Oh, okay, we're all good.
Wait, so was that correct or was that incorrect?
They give him the point for it.
Oh, okay, so it was correct. Oh, that's
Yeah.
crazy.
Wow, good work.
Oh my
That
god.
is a
Yeah, it was.
hard thing to know at the moment.
The correct answer says -9. Wow.
Whoa, that is cool. That is a very.
It
cool
all
answer.
simplifies to -9. That is crazy. Wow.
Yeah, I like
And he
that.
got it like almost near last second too. So
Yeah,
if,
really.
if you didn't catch that too, man.
That would be rough. Especially after doing all that. Dang.
Yeah. But I would have never imagined that. I would have guessed 0, honestly.
3,
But to the next integral,
1, integrate.
I know
We
0
have
wouldn't even been bad yet there.
from 1, if I could make sure, yeah. From 0 to pi over 2. Oh, okay. I know.
1 over 1 plus cosine all squared.
Squared. I remember there was a very sneaky but ugly trick to this. The ugly trick to this is to let u equal 1 over 1 plus cosine of x. Can you imagine that? You can actually do that, yes. There was an ugly trick to this where you can let u equal 1 over 1 plus cosine of x. And it actually simplifies everything.
No way, that's
Yeah.
crazy.
I learned that from like a very old Cambridge University calculus book. And it was the integral like this, but it was to the power of 4 at the denominator.
Oh.
Yeah.
Does it work for any power or just like even ones or little
I'm
ones?
actually not sure. It's a good question.
It
One.
looks like they're trying to see. Well, the person on the right might get it. I think it seems as though they've tried to figure out what the derivative of 1 over 1 plus cosine x is.
Person on the left is graphing. I see a graph. It was like a unit circle.
No way. If we're in another contour integration, I'm gonna lose my mind.
Oh, is that what it is? Oh, I can't tell. But if that was the case, that would have been crazy.
That would be wild. Okay, they seem to have
Okay,
scrapped
so
that idea.
Okay. It really looks like the person on the right is actually doing that U sub that I was talking about.
Oh no, they've opted for just doing u is equal to cosine.
Okay. Gotcha.
Which, honestly, you would be able to use. Oh no, no, you'd be able to use a beta function for this one. If you break up the. Oh no, you can't. No, it's 1 minus. So you could do 1 plus u, 1 minus u,
Mm-hmm.
and then break it up into a beta integral. If you do, I think you just need to distribute.
Oh, no. Person on the left is still trying to graph it and try to conceptualize. Maybe a little bit of symmetry. But I don't think
Yeah,
it's
I'm not-
symmetrical at all.
No. I wonder what intuition they have to graph it.
Yeah.
We're at a minute.
Chat says Weierstrass. Would you use Weierstrass?
I would not. I am not confident enough to manipulate polynomials like that.
Yeah, no, same. I would not have the guts to do Weierstrass on this integral.
No, absolutely not. I think people in the chat have some of that IMO algebra brain, and yeah, not me.
Mm-hmm. Ooh. 10 seconds. Oh no, 17, 16 seconds left. Yeah, they both seem to be very stuck. Trying to find a way out. But I don't think they'll be able to make it in time.
No.
Time's up.
Dang.
Dang. Well, I mean, we got 1 point in, so he'll be moving forward. I think that's it. Yeah.
Yep. Dang.
Yeah. The answer was 2/3. Very nice.
Yeah, that was a solid guess. I can't even lie.
I think what I would have done is I'd probably do like secant square top and bottom.
Yeah,
and then just do like a basic U sub.
Hey, when in doubt, just multiply.
Multiply secant square.
Yeah, every time.
Every time.
Yeah, without fail. That's a really cool problem, though. I feel like
Yeah.
I wonder if you can generalize that for different.
For different powers.
Yeah, that'd be cool.
Dang. Man, I'm still shocked by the improper integral.
Yeah, me too.
Yeah, this is crazy. This integral here. Oh my god. I would have never imagined a polynomial improper integral like this.
No.
Ever.
That's very. But these some of the Austrian writers, it looks like in Austria a lot of their curriculum is based around like the solving of improper integrals and stuff like that, where they do a lot of work in convergence and stuff, even in their lower level undergrad classes, and so they absolutely love to argue with me about whether or not my integrals converge all the time.
I think we're going into semifinals right now. Let me check my quality. Okay, it is at the highest. I think I have the bracket here. But update. I don't know if they updated it. No, not yet. But it'll be there. But I think we're about to get started straight into semifinals now.
But I think we're going to have some interesting competition here in the semifinals, because I think a lot of these guys are very skilled.
Oh dang!
So it should be pretty interesting to see how these guys tackle some of these harder integrals.
We are done with easy integrals, some more trivial topics. And now we are starting with some serious stuff here.
Oh yeah, that's another IMO shirt.
Oh wow, yeah, that is.
A two-time competitor.
One. Integrate. Oh boy. Oh wow. We have. See if I can find that integral.
It's be.
Okay, it's in page 12. Okay. Yeah. So we have. I could slowly. There it is. Wow.
Yeah, this is I wrote this one. This is an evil problem for sure. But
really?
I think.
Oh dang.
Yeah, this is but I would say it's very fun. The guy on the left has the right idea. If it's very doable. But I like this one a lot. This is a cool problem.
I mean, I feel like it's just like what? Probably just generalize the derivative. Oh, but then that sum, you have to do something with that sum. Okay, I didn't see that. That sum is connected with that derivative. So it's not just the nth derivative, it's the... Oh, actually, you could generalize that nth derivative and put it as this, and then compute the sum with that generalization. Okay.
But so a lot of the sum is important there because a lot of the terms with the derivatives cancel out only after summation. So if you don't generalize, you'll end up with a really gross-looking, generalization. So it can be very tricky to
like the one on the right. I see combinatorials and I'm freaking out.
Yes, that is exactly what it is. Exactly the problem.
Oh my god.
Yeah, so that's why you don't want to. It can be really easy.
Oh
Problems
god.
Instinct to generalize, but the trick is with x e to the negative x, you can, if you know how the derivatives of that work, they end up canceling out.
Oh
And
my
it
god.
looks like the guy on the right here, or on the left, is very, very close. Very, very
Yeah,
close.
that looks right. Gamma function is all you need.
Yeah, but I will say, I don't think that is correct. But, oh, actually, yes it is. So, he has the correct answer right here on the left.
Okay.
He just needs to, I mean, hey, circle it.
Oh no. Something went wrong?
It looks like it. It looks like he changed his mind.
Okay, they have over a minute left.
Maybe.
So that's
Yeah, so he's
still
got plenty of
good
time.
enough
He's got
time.
plenty of
Yeah.
time.
That's still
Yeah.
good enough time.
But it looks like he's just going back and checking his work. So. There's under a minute left here, and he does seem to have a good answer.
Oh my god.
Guy on the left seems to have generalized the sum, and is now probably not having a fun time. Oh, I think that
Oh,
that
no.
minus there, that minus is what's gonna get him.
Yeah. That minus is worrying me.
Yeah.
15 seconds already.
Oh, yeah, he's stressing.
Oh no.
Oh,
Come on.
he's gonna. Yeah, he's gonna
So
be kicking
close.
himself.
Divided. Oh, E.
Oh, no
Oh, is that
way!
right? Oh my god! Yo!
Oh,
Almost
he
last
had it,
second.
He had it. Wow! Oh my gosh. That is crazy.
crazy.
Absolutely fantastic job.
Holy hell.
Oh my gosh. What an amazing last second change. Oh my
God
gosh.
dang.
Holy moly.
The adrenaline is kicking in.
Yeah.
Oh my god. I feel so bad for the person on the right though. I saw that double sum and the combinator. Oh
Yeah.
god.
Not good. Not good.
Fell into a rabbit
that's-
hole that you don't want to be in.
No. But it looks like he was able to honestly get out of it pretty good, and he was very, very close to getting there.
Uh-huh.
Like you can see right there on the bottom term, it looks like he has two, like, almost gamma functions that kind of end up into sums. So, I wouldn't be surprised if he was able to get there way. Maybe he had another or two, but that, yeah, it's just hard. Wow. That is
Holy
wild.
I did also realize, so before I did a little bit of research, not stalking, but most of the IMO competitors here that participated in Integration Bee in Vienna, most of them are, I think they're almost all silver medalists. It's crazy.
What?
Yeah.
That is wild.
The majority of them are silver medalists. I cannot read that. What the heck? That is long. What is that?
Okay, it is. It's.
Oh my god. Oh, they need a
This is
speed
another-
dash.
Yeah, this is another evident.
Oh, there's a factor. There's a common factor. They gotta do it immediately before someone else gets it. Oh, come on.
I was
Oh, they're
hoping this
both
wouldn't happen.
now the show's really getting intense. Now it's about who can get it first.
Yep.
Oh, the person
Yeah,
on
this-
the left is
They're trying to simplify it. Oh, looks like we're in some ruling here. I think there was a question about the integral. It looks like
Oh,
they're going
okay.
at it. Yeah, it looks like he's trying to use polynomial division to try to simplify. And for those in chat, yes, it is 1 plus even powers of tangent up till the 10th. But I'm honestly not sure how much polynomial division here was about. You might be able to do some nice simplification here.
It seems like.
Especially because
Yeah.
I think that might be a good approach though.
Oh god. Oh god. The 1 minus tangent square, I feel like that might mess up a little bit of everything. Oh wait, actually? Okay. He let u equal tangent x.
Mm-hmm. So
Okay,
he's gonna
never
get
mind.
1 over 1 minus x to the 12th divided by 1 minus x to the 4th. So he might be able to do some cubic simplification here to get rid of that 1 over x to the 4th.
Hmm.
Which it looks like he saw. Wow. Yeah, he did do the cubic simplification.
Oh my god.
And that is correct. Holy moly, this guy
Is it really?
cracked, dude.
Oh.
Yeah, that is. Holy moly.
Oh come
He's
on. Now
wild.
you just have to
He's
circle
crazy.
it before the other person finds out.
Oh my goodness.
If he circles it, then this round's over.
It's right.
Oh.
Oh my
Oh.
gosh.
Circle it. Come on.
Come on.
One.
Yeah.
Yeah.
Goated. He's goated.
That looks right.
They're gonna open out the calculator.
14 plus 45. Yeah, that's 59. Yeah, that's correct.
What?
Nice. Oh my god.
He's nuts, dude. He's nuts. Oh my gosh.
Really amazing.
Oh, he's goated. Oh my gosh. Yeah, somebody in chat says green guy needs to be patched. Mobs, go ahead and ban him.
I think that's is that it? Or are they still continuing?
I think it's best of 5. No, I think semifinals. I think finals are best of 5, but semifinals are best of 3. Maybe they changed it.
Oh, they might have changed it.
Yeah, well, it looks like they're still standing up there. So maybe it's
Okay.
best of 5.
So okay.
But also factoring would work there. You could factor out tangent of you could turn the 1 plus tangent squared into secant squared.
Square.
and
Yeah,
solve
that was my first approach.
Yep, and then you basically can get a secant square out of every single term, and then you get the same polynomial here.
3, 2, 1.
Very impressive.
Integrate.
Wow. And
Oh,
seems like that is yeah. We have
this is another one of mine.
from 0 to infinity, x to the power of negative log of x dx.
Yes. This is a cool one.
Some loophole log here and there. I think it's just a little, pretty much a Gaussian integral, but you're gonna have to do some completing the square on that exponent.
Yeah. Which I'm not sure if on the left we're seeing that.
Oh my
it looks
god.
like he did.
The chat, someone in the chat says the green guy needs to be patched. Oh my goodness.
Oof.
But no,
This
that's
is
the correct way.
Yeah, for sure. On the right, it looks like they went immediately to try to do an inversion almost,
Oh, dang. Whoa.
which I would never have seen in all my years. But that is very impressive. That looks like, honestly, that doesn't even look too bad. I feel like that might work out.
1 plus 1 over x squared. Oh, I think he scrapped that idea.
Oh. Yeah, I think you might need to be able to.
2y.
Oh. Yeah, there it is.
E negative log square times 1 plus 1 over x squared. Can you do integration by parts with that? I never seen that.
No, me either. Interesting.
Wow.
Oh. It looks like he's trying to factor out the top exponent. I'm hoping he realizes he has to go square there, but
Yeah.
I think the bounds are throwing him off here. Yeah, he's getting a gross U sub out of this. He's trying to see if he doesn't have to use Gaussian.
Hmm.
Oof.
Oh no.
Yeah, this might be rough.
Wait, what happened to the bottom? The lower bound. When he did x
Yeah.
equal e to the u, shouldn't the lower bound should have been negative infinity.
It should have. I think that's what's messing him up here, because he's not getting a minute left. Oof.
Oh no. Taylor series?
Oh. I don't know.
I'd be so
I'm not-
impressed if that actually works out.
Yeah. It looks like they're both coming up with answers different from a Gaussian, which is interesting. 30 seconds left. And it looks like the guy on the right has the Gaussian, but he just needs to fix his lower bound as well, because he had the original lower bound. Oh, -1. That is
-1.
definitely incorrect.
Oh, e square.
Also
Yeah,
incorrect.
no. Should be square root of pi, square root of e.
Yeah. Dang. All right.
Ah,
I do think that we have one more Gaussian, so I'll be interested to see how that goes. But I think that's in our tiebreakers, so
oh, okay.
it'll be interesting. Wow. All right. Looks like we're gonna keep moving.
Yeah. So just one more integral then?
I think so.
Oh boy.
All right. This will be interesting.
Oh no, two more integrals. Depending if one of them gets it.
3,
Yeah.
2, 1, integrate!
Here we go. We have what is
This is a 4-function integral.
oh, it is a
It's
function
from
integral.
1 to infinity of 2 to the, I want to say, -4 of x divided by x squared. And guy on the left has already turned into a sum. He's on it.
Oh wow, nice. Good start. Good head start.
Oh, and as well on the right. The guy on the right has also turned into a sum, so they've both seen that already.
Nice.
He's got to move on these ones.
Ooh, okay. Person on the left is just already got the antiderivative. Now it's just computing the sum and that's it.
Yep.
Ooh. Now it's about who's gonna get it first. How fast they can get it. Oh, they're both actually got. Oh god.
I know. You guys
Oh
are
my
flying.
God.
They're flying. They need to stop writing the sum down. I think it's slowing them.
Oh, they're both locked in right now.
I know.
Ooh. The n squared plus n at the denominator sum is really distracting. They got a partial fraction it. Oh, and that's what the person on the left did immediately.
Wow.
Oh, they both have it already. Oh my god.
I think honestly, if you just multiply it into 2, you could just compute the second antiderivative of the generalized form for a power series.
Oh dang.
And I think that's to do. I think that's the fastest way of doing that. I didn't write this one, but it's a cool problem. It's a very cool problem.
So I think that would be the. I think that is the way to go.
Yeah, I think that avoids needing to compute two different things. But they're both right there. I mean,
Oh my god, it's just right there.
2 minutes left. 2 minutes left, and then they're basically already at the end. They just need to compute like the last of the sum here.
I don't think they're worried about the time limit. They're worried about who's gonna get it first.
Yeah.
They're trying not to mess this up, because if one of them guesses wrong, then it's a win to the other person.
Yep.
Or it would be a free point to the other person if they guessed it wrong.
Yeah.
And I think both are trying to avoid that. So they really want to make sure that their answer is actually correct.
Mhm.
But time flies by, so I mean it's down to almost to a minute.
It looks like you wrote down the wrong power series for which, honestly, because the correct power series is log of 1 minus x, if the x is 1/2, it doesn't matter if it's 1 minus or x. So that is a good coincidence for.
Oh my god. They're both just right there.
Oh
my god. They're both just right there.
30 seconds left.
Oh my god.
I think they're both trying to do it analytically, which is interesting. Oh, and he changed it to the correct power series. Okay, so it looks like
nice.
he just needs to write. He just needs to write down an answer. I think both of them. I think both of them have the power series down, and they just need to write it down. Oh.
Oh my god.
Oh, we have an answer. Oh, he changed it last second. Wait.
Huh?
Oh, he had it correct, I think, too. I think he's off by a constant.
Oh no.
Oh, man. It's bad.
Oh
He
my
doesn't have a name.
god. Oh.
No, dude.
Oh.
Alright. Woo! That was moving on to the next one, it seems.
But I mean, that's okay, because, I mean, 2 points in the lead. Yeah, they declared him as a semi-finalist.
Wow.
I mean,
holy moly.
Yeah. Not semi-finalist. I think that's just straight to finals. Or, yeah. Oh my god. Finalist already.
Wow. Yeah, these finals are going to be very, very interesting.
Holy hell. I could go back to the problem. Yeah, 1 minus ln of 2. Yeah, it's like pretty much a arithmetic geo series. Wow.
Wow, that's super cool. That's a cool problem.
Yeah.
Oh, got some votes up right now.
Oh.
For who the winner will be. That's pretty funny.
I completely forgot about that.
That's wild. It looks like the current votes are for W. She. I'm not sure who that is, but
Oh my god.
Fun fact, most of the votes are after we announce the result.
Yeah, so the audience is voting who they believe would be the winner. That's crazy actually, because William Shi, Dominic Potar, and Lugu, they're all, I think they're all IMO silver medalists.
oh my goodness.
Yeah.
Yeah, we're gonna have an absolute cracked finals.
Alrighty. Our last semi-finalists. Here we go. Oh man, finals is going to be crazy.
Yeah, finals gonna be crazy.
You can already
Either one
feel
of
the
these two
energy.
moving on is gonna be
Dang. Alright, we're gonna begin.
1. Integrate.
Seems like cosine ln of
I think
x?
it's
Yeah.
I think it's 0 to 1 of
0 to 1
cosine
cosine ln of x. Oh, you know exactly what to do. Oh, and I think the person on the right is going diving straight into it.
Yep.
Integration by parts? Okay. Not bad. Although I believe if you do integration by parts, it's gonna put you into a recursive integration by parts, I think. Because you get sine of ln of x. And you would have to do it again.
But then after that, I think it's doable.
Yeah.
You got a finger in frame.
We do have a finger in frame. But oh, I think
they're getting.
oh, I
Oh my
think
gosh.
yeah, they're getting it. Now they just have to add that integral to the other side and divide by 2.
This is one of the more interesting ways I've. That's very impressive. Wow.
Oh my god.
That's crazy.
That is
They're
a
absolutely
very
smooth.
fast integration by parts.
Yeah. Holy moly, dude. Now it's just plug and chug and then they're there.
Yeah.
The only thing I see a problem with is that 0 bound. That lower bound might screw him here.
Oh, because it's negative. Oh no.
You get cosine of infinity minus sine.
Oh no.
Which-
Oh.
Oh.
Wait, but ln of 1 is 0.
Yeah, they just didn't simplify any of it. They just
Yeah.
assumed the zeros went to 0, the negative infinities went to 0.
I mean, it's still
And I
that
think they-
looks correct. 'Cause that does equal a half.
It's 1/2. So.
Yeah.
It is a funny thing to do that. With a minute 55 left, they just decided to not simplify. Oh, that's funny. Wow. Great play there.
Yeah.
1/2, they get it right.
1/2. But yeah, no, the
My first step there would have been complexify. That
Really?
would be what I would do.
I would just let
Yeah,
you equal
I
ln
know.
of x and
Oh.
call it a day. So complexifying, complexify because you just
Yeah,
get
you
polynomials of, or just it's just power rule, right?
Yeah, and so I would have. The only hard part becomes just complex algebra. So.
Oh, that's true. Yeah, because you have to put it back in real form.
But when it bounced from 0 to 1, you'd end up getting a bunch of easy junk. So It wouldn't even be that much complex algebra.
Integration Bee.
Alright, off to our second
3,
integral.
2, 1, integrate.
Oof.
Is that a floor function?
Yeah, it's floor function of 2025 sine squared. All inside the floor from 0 to pi
From 0 to pi
over
over 2. 2025
2. This
squared.
is a,
Oh my
this is
god.
a homomorph integral, I will say.
I can see that.
Yeah, I'm not gonna lie. It's not even that surprising. Just based
Oh, it
off
is.
looking at it.
I didn't even know. I just saw the
Literally
document.
is, you know,
I
it's a
saw-
problem. That's a problem.
Oh my god. Oh, the graphingness. Oh god.
Oh, that's see. I mean, this is a gross problem.
Oh god. I just
That's a homomorph problem.
I feel so bad for these two competitors. The graphing on this, you have to be. You either bash the graph or you're bash the bounds.
Yeah. Holy moly, this is gonna be interesting.
Oh god, I think both are. I think I see a graph a little bit slightly, but I think they're also trying to find. Like, oh, wait a minute. The person on the right
Yeah.
has a bound that I've never thought about.
Arc sine of 1 over square root 2025. It looks like they just usupped out everything inside the floor function,
Oh, okay.
which
'Cause
is
That's one cheap way to
Crazy.
go about. one cheap way out. I think I would have done the same thing. I never thought of it like that. But I just feel like I don't know how that's gonna help because now you have that arc. That arc sign bound is like really distracting, and it's a sum
Yeah.
from 1 to 2025. Yeah,
yeah, this is just gross all the way around.
yeah. Oh, we have an answer.
Oh,
Yeah, I'm about to say. Oh,
2025 times 1012,
interesting.
and it's wrong. Incorrect.
Ooh. All right, now the guy on the right has some time. Got about a minute 40 left over. A little bit under.
Okay. $20.25 sine square. Oh god, the bounds. The bounds.
Yeah. The bounds are
Oh, that's
disgusting.
so nasty.
What?
Oh
I
god.
minus
I
one.
minus 1 D. Oh my god.
going
And you have
on?
like less than a minute left.
Oh.
I mean now at this point you're just going against time rather than the opponent.
Yeah.
But it's still at this position it's scary. Heart's racing, you're just trying to find an answer at this point.
Ooh.
Less than 30 seconds left.
Yeah.
Oh my god. You actually have to compute that too. You can't leave it as is.
No, I think he's just gonna probably that. I don't think.
Oh no, you can't leave it! I knew that was gonna happen.
Yeah. Oh my gosh. Oh wow, what a beautiful solution to this problem.
Yeah.
No, it does not, and I don't think it telescopes either. So
Yeah.
I think there's some closed form for that arc sine expression that obviously I'm not gonna be able to see. This was disgusting.
506 pi.
Yeah, I would love to see the solution to that. That's crazy. Oh, I think Lucas might have this too.
Oh, dang. Trig identities? Floor identity? Oh. King's rule is the way. That's crazy. I did not think about that.
Oh, I remember, okay, I remember it now. I think he discussed the solution to this. I think you do King's rule to get into cosine, and then you can add them together to simplify it. If you add the two integrals together, I think it's something to do with the fact that they're really integers or something, and you can simplify out the 2025 to get 1, and so you end up with 2025 divided by 2025 times 2 pi, or times pi over 2, then you divide the 2 over from the 2i, so you get 2025 divided by 4 times pi.
Oh, dang.
Which is 5 over pi. I think that's the solution, which is one of the craziest solution developments for that type of integral. For sure, that's a hard one.
Yeah, I would have never figured that out. I didn't think
No.
you could do that.
I think it's you're relying on the fact that since they're both integers.
Hmm.
1. Integrate.
Third integral? Is that a,
Same
oh, what
exact-
happened? Oh.
3, 2, 1. Integrate.
We have a limit integral. Oh, no way. Oh my god.
Yeah, you're gonna have to pull this one up on screen.
Limit to n approaches to infinity. 1 over square root of n. I'm freaking out just looking at this. I'm already.
Yeah, and then
Oh
the
god.
integrand is n times e to the x times 1 minus n. Oof.
Holy hell. Oh, we have an antiderivative. Okay.
Oh my gosh, that was yeah. I mean, yeah, it is a very basic anti.
But you have to be very careful though, because you don't want to. You can easily dive into divergence. If you there are some cases where if you just compute the antiderivative first, then you can accidentally dive into divergence. In some cases, you have to manipulate it more. Sometimes even compute the limit first and then the integral. But I don't know how it's gonna work out.
I would have u is equal to nx. I think is my first bet here.
Yeah, I do the same thing too. I think that's the best way to go about this because you have that n. It gets rid of that n at the front. Huh. They got 0? Yeah, that's very sus.
Yeah, I don't think
You have to be very careful. You're gonna have to work your way around this. That's very suspicious.
Because you get 0 by just plugging in infinity to the bounds. So
yeah.
that's definitely
And I think he's realizing that right now.
yeah. Honestly, what might work here is if you drop the 1 over n down to the denominator, or you drop the n into a 1 over n. Oh, positive 1.
Oh, is it really positive 1?
Whoa!
What? Is it really? No way. It is 1. Oh my god.
Holy crap!
Wow. And the person even knew there was something wrong too. The person knew there was something wrong. And so was just like, wait a minute.
But yeah, I think you'd be able to pull out the
the
n into a 1 over n and the denominator.
Oh my god.
I think that might clear stuff up a little bit more, but I don't think that's what they did. I have no idea how they got one. Wow,
Jesus.
very impressive.
Huge
Very
W.
impressive. Huge W. Right
Huge
there.
W.
That's-
Oh my god.
All right, next integral.
Alright.
Oh,
Oh
This
my
is-
goodness. What is this?
limit as n goes to infinity the sum from k equals 1 to n from the bounds of the integral being k to n of k to the 2024 divided by...
Oh my goodness.
Holy crap. I do not know at all. I mean, this is absolutely ridiculous.
Wait a
I
minute.
am-
Wait, hold on. Wait, that N is very sus. Oh no no no, the
I
K.
think
Is this a Riemann sum?
Oh!
That looks like a Riemann sum. If they can
It
figure
might be!
Yeah.
No way!
Now let's see if it has they have to let's see if any of them figures that out. And notices that it's a Riemann sum.
Wow. I would have never seen that in a million years. My
Yeah.
first guess would have been dividing by n. I think I don't even know how much that would have helped. Actually, when I'm looking at it, but my thought process is just to get the x alone. But then I realize you of 1 divided by x to the 2026 plus 1, which is not helpful.
Oh my god.
Whoa.
Oh, I might be wrong. Maybe it's not a Riemann sum because you have 1 over n squared left rather than 1 over n.
Ah. Wow.
Oh no no no! I lied. No no no! You can. Yeah, it is Riemann sum because even though you have 1 over n squared, you also have x over n, and you do a u sub, and that cancels 1 of the n at the bottom,
Oh.
and so you get 1 over n after the u sub, and then it becomes a Riemann sum.
Yeah. This is I think an integral by one of our past competitors. And
Yeah,
definitely one of the coolest integrals I think I've ever seen.
it's a very nice integral. That u sub and then the Riemann sum is a very slick move. I really like that. But I don't think any of these competitors notices is that. I think they're just
No,
messing
I
around.
wouldn't,
They're
yeah.
just messing around with the rational function. Oh god. Person on the left seems to be stuck. Trying to
I
like
can't.
find a way to unwrap this integral. Person on the right is just trying to throw as much possibilities. Try to get out of this this awkward position. Try to find a
It looks like
sneaky.
they try to do almost King's Rule on it.
It does look like King's Rule actually. 0.
That
Yeah.
is definitely incorrect.
It's definitely not 0. Oh, I didn't even realize I have 10 seconds left. Oh crap.
It's just, I mean,
I square over 6. When in doubt.
yeah, put it down. Genius, genius. Oh, God, I would have never gotten it.
Oh my god. Well, there we go.
Alright, that's it. There's our finalists.
There's our finalist.
Wow.
Yeah, the answer was ln of 2 over 2025 times 2026. Yeah, I feel like it's you divide top and bottom by n to the power of 2026, You will get 1 over n squared, but don't let that bother you. You know, you just let u equal x over n, and then you get 1 over n. And then it's a Riemann sum.
Then we come back for the match for third place, and then the grand final.
Alright. Alright, so we're gonna take a break in between. After this break, we're gonna go straight into finals round, which is going to be crazy. Oh wait, don't we have third place match?
Ooh, I would think so.
I'm not sure. I think I have it pulled up here. First off, I can go ahead and check if there's. I just noticed. Okay. Put in brackets. Yeah, so here's an updated bracket right now. We have Dominic Potar and Flugu. And I think both of them, I believe, are IMO contestants. Silver medalists. So we're gonna have IMO contestants going at it against each other in the finals round. It's gonna be crazy. Very intense. Oh my god, can't wait for that. Third place match. I am checking. I don't. It doesn't say. Finals. Quarterfinals. Best of 3. Okay, yeah, it seems like we don't have third place match here. I believe. Timer. Yeah. Seems like we don't have third place match, so we'll just go straight into finals. Best of 5. Yeah.
Wow. And this best of 5 is gonna be intense.
It's gonna be very intense. Yeah, from these two integrators. It's gonna be extremely intense. And surprises might happen in the break.
Yeah.
Oh boy. I'm still tripped over with that polynomial improper integral.
Oh my gosh, that was so cool.
I refuse to believe that integral converges.
That's crazy.
Just having an
that's
absolute value. That's crazy.
Wow. That is so wild. Yeah, it's absolutely nutty.
Oh my god. So when in doubt, Zeta 2. In the chat.
That's awesome. Yeah, for real. I feel like it's just such a sum. I can't even argue with it. Especially when you got those gross sums like that. It always ends up being something or something familiar.
Yeah. I really like this Integration Bee. The fact that they do it semester rather than annual.
Does anybody have?
Yeah, I feel like it gives people more of a chance to kind of like. It gives you much more of a chance to compete. Like, you're able to be in front of like real life people a lot more, which I think is always a good thing.
Yeah. You don't have to wait a whole another year. You know?
Yeah, right.
God.
It's.
Max, stój, no такая же.
I know. I wish there was more integration bees in that happens so frequently in the States because
Yeah.
you know it's like dry for it's only really like it's like Berkeley and MIT and that's like
I think the majority are annual, yeah. Majority are annual, sadly. But I'm just kind of waiting for the surprise. I don't know, the website says there's a surprise in the break, and I'm just kind of anticipating what the surprise is. But I could be wrong.
well, to be honest with you, I also do not know what the surprise is, so I am also excited to see what happens.
Unless.
Unless. Oh, Max says they're gonna restart the stream.
Oh, restarting the stream? Okay.
Maybe that's the surprise. That we restart the stream.
Okay. Holy hell.
Oh my gosh, dude. This is these finals integrals are challenging to say the least. They are going to be very, very hard.
That's gonna be nice because I mean, from what we've seen from those two competitors, our finalists, right? They both speed integrated very quickly. So to seeing both of them trying to figure it out and race each other, it's going to be very entertaining.
Yeah, definitely. I'm excited to see how they both tackle some of these integrals.
Yeah. Alright, I think they're about to restart. Yep. So while they do that, I'm gonna put my screen onto the bracket. Wow.
Oh, also, Silver, I found a close form for that cosine one.
Oh.
I just sent it in the Discord, but it's got like an interesting someone, and I used half angle identities to do it.
Oh, dang. Oh, there is a
Yeah.
closed one. Oh, wow. That is crazy.
Yeah, if you use half angle identity, you get it into a secant generalized integral, just secant to the 2n,
Mm-hmm.
and then you change it to tangent, and you get a binomial theorem in there.
Oh my god.
But yeah, because you get like if you do secant to tangent, then you can get a 1 plus like x squared to the power of n minus 1. So then you get that binomial theorem, then you just integrate.
Okay. Let me actually, hold on. I'll pull up my OBS just a little bit. Let me go like this. I apologize. I just need to make sure that I think I'm gonna be okay. Yeah. So they'll see my Discord here and there. Alright, I'm gonna pull back up now. Well, there we go. Thank you guys so much for bearing with us. I really appreciate it. But holy hell. Yeah, so if I go like this, I think they won't mind if I pull up the Discord. Yeah, I think if I go like that.
No, not at all.
Yeah. This is what I was talking about. Yeah. The 1 plus cosine of x here. Yeah, this, you can actually do a u sub, letting u equal 1 over 1 plus cosine of x. It is crazy. It is surprisingly
that's so
crazy.
Cool.
Yeah.
That is so cool.
Surprisingly, like, simplifies somehow. But...
Well, yeah, that is a really neat simplification. I wonder if there's any like more simplified you can get it, because I feel like that even it's a nice simplification for like a gross looking, but I feel like even then, like if for any higher power, it's like going to be impossible to compute in like any reasonable time.
Yeah. Yeah. Thank you guys, whoever's in the chat. Thank you for bearing with us. I think I think they're changing the stream to kind of. I think they're either replacing something, because I think I heard Max said something about a cable, or a charger.
Here's the link. I think this is the new live.
Oh, they're live again?
Yeah.
Okay, let's go. There we go. Make sure it's automatic. Oh, I think they changed cameras.
Yeah.
Oh, okay. Got it.
Короче, да, надо было бухать. Не надо было. Короче, бан не наебешь, сквозь пространство времени не пройдешь. Это по поводу призыва.
I'm very excited to see this.
Yeah, no, I'm really excited. This is gonna be intense. Oh man.
Ooh.
Again, 2 IMO contestants, silver medalists.
Oh my gosh, I cannot believe the two silver. Are they both Austrian IMO contestants?
Yeah.
Wow, that's wild. Do you know what year they did it?
I don't remember. Let me check again. Let's see, Austria. Individual results. If I could, let's see. So Dominic Potard, from 2024. I'm sorry. 2023-2024 for Dominic Potard. Flugo is 2021. 2021. I only see 2021.
Oh wow.
Yeah, they're both IMO contestants.
That's so
For Austria, yeah. William Shi is also 2024 as well.
Wow.
Mm-hmm.
These guys are probably freshmen.
Yeah, and then they're showing the brackets, which I have pulled up here as well. It's crazy.
Oof.
Oh my god. Let me actually go like that. There we go. Wow.
I know these guys are really gonna battle it out here. I think that's gonna be very interesting.
Oh yeah, they're gonna bet. It's gonna be both strategic and speed. It's gonna be very very intense.
Yeah, I think a lot of the first few integrals for the final, seeing the trick to them as soon as you can.
On a scale of 1 to 10, like how challenging do you think the finals are gonna be?
Oof. I would say maybe an 8, maybe a solid, maybe steep 8. Yeah,
An
I think
8.
these are pretty rough. I think semifinals maybe a 6 or 7. I think finals are nice 8.
Compared to oh dang, okay.
Yeah, so they're definitely harder
Ooh.
than semifinals. But
A solid 8. That's what I like to hear.
yeah, we there's a couple of comparatively easy ones there,
Uh-huh.
just to ensure we're able to keep things intense. You might get thrown a lob where you know what to do right away, and just smash it down and be able to score fast. Some of them definitely take a lot more care.
Okay.
And then there's one or two in there that are just straight up evil. So you can look out for those.
Just straight up evil.
Yeah, just straight up evil. That there's just
Oh,
gonna be
man.
despicable evil in movies. But it should be interesting.
I just want
There's
to check.
one of them that I low key hope that too low, because the last final we've set up is one of the coolest integrals in this competition, and it's very, very cool. And if we don't use it this semester, we're definitely going to use it. So I'll be very excited to see if we end up.
Hopefully. Best of 5 for finals round. Best of 5. And I both got 2 points too. So it's gonna be crazy.
I know.
Alright. To the chat, we're just still on break, but we're about to after this break, we're just gonna get into finals round. So sit back and get your snacks ready.
Yeah. Get out the popcorn.
Get out the popcorn. This finals round might be a bloodbath.
I think a bloodbath is probably the best way to describe it. I mean,
Oh shit!
this is gonna be very, very.
Oh boy.
Because I think a lot of them don't just rely on your ability to integrate, but your ability to handle other things in different mathematics. I think some of them are very heavy on integration, while others can be very heavy on like your ability to like notice things like geometrically. That, but I think this should be fun nonetheless.
Ooh. Oh my god, in the chat someone said all the functions are gonna collab in the finals problems.
Yeah, we're gonna get some despicable one in here.
all the cool obscure bizarre integrals that we've seen will be combined in the finals round.
I think there's gonna be a couple where it's like very immediately clear what to do, and it'll just be about who can see that faster and do it faster. And then, but then there's gonna be some where you're looking at it and you're just going, "What the hell am I doing?" So, I think it'll be an interesting finals round for these two. I feel like these are the best to participate in this finals round because they clearly have such a deep, like, understanding of these sorts of problems. So, I think it should be interesting. And it looks like we might be about to get into it.
Oh boy. Just want to make sure. Oh, I think we got a new stream. Let me go ahead and check on that right now. Site. Oh god. Okay, no, it's the same stream. Okay. I just want to make sure.
We can do it.
Yeah. We're about to start. Oh no. There we go. Oh, we are having a third place match.
Yeah, it looks like the small final round.
Okay.
I always forget they call it small finals, but yeah, this will be for third here. This will be interesting. I think
boy.
we just use the semifinals. I think it's just basically a
Okay.
bracket for semifinal.
Gotcha.
Integrate.
Ooh, the
Alright,
integral
ready to do
square root of x over 1 plus square root of 1 plus x dx. Ooh.
it. Oof. This already looks gross.
Yeah.
My first thought is conjugate it immediately.
Yeah, that's what I would do too.
That's what I would do.
Well, actually,
Or maybe you could do like a sinh squared sub.
that, yeah, actually, that seems to be a good approach. Yeah. Let x equal sinh square theta. That might be.
It looks like on the right we have x is equal to tangent squared. So let's see how they're able to get their way into this one.
Yeah. Advanced trig sub also does the trick. I think that's exactly what the person on the right is doing. Advanced trig sub, letting x. Oh, well, yeah, they technically did that. They let u equal square root of x and then tangent theta.
Mm-hmm.
Ooh. That looks like... Is that conjugated correctly?
I don't know.
Oh no.
Oh, this might be
The
bad.
person on the right accidentally miscalculated the simplification on the denominator.
Dang.
Yeah, that's... Oh, answer?
What?
Yeah, no, that... I don't think that's correct.
I don't think that is correct. Yeah. Yeah, that's where the simplification will really get you.
Mm-hmm. Yeah, the x at the bottom, it's not square root of x. Yeah, that. Oh.
Wow. Yeah.
Yeah.
Damn. He realized right after.
Yeah.
Yeah.
I don't blame him though. 'Cause when you're rushing, especially like racing against, you know, it's you're just trying to just look ahead and just try to like answer it quickly. But sometimes some small algebraic manipulations can get us sometimes. Now it all depends on William Shi. Oh man. make sure that what's the highest quality I could go? 720p. Casting a spell.
Putting a hex on.
Is that allowed here in Integration Bee? Are we allowed to hex our opponents with magic?
Do something, please.
Ooh. I don't know. Incorrect as well? Oh no, they're still checking.
Yep. And I don't think they have that arc cinch, but he might have it in terms of LN, which could prove to be interesting.
Yeah.
But it's not an easy answer from here, so you have to rely on
Oh, okay, yeah. No, incorrect as well. Alright.
Alright, we're
Moving
moving on
on.
to the next one.
Yep. Is this third place match best out of 3 or best out of 5?
I think best out of 5.
Okay. Oh boy. The anticipation is scary.
And I used the Max did his bachelor's thesis on the ELOs that you can see on the website for everyone in chat, and he made a program that essentially calculates the probability of winning for any people on their Integration Bee ELO.
Hmm.
Current probability
Oh my god, what the hell?
Okay, what is this? This isn't me, guys, I promise. This
What?
one's ridiculous.
Wait. I need to make sure. Oh my god. The 2025th derivative of e to the x square? Huh?
Bro, what? That's gross.
That is disgusting. Indeed, nasty. Brother in the chat. Oh my god. What on earth is this? Oh my god. No, ain't no way. There has to be some shortcut. There's no way you actually have to find the 2025th derivative of that. There has to be some sort of shortcut.
Maybe do u sub. U is equal to x squared.
Yeah, that's what I was thinking too, but then it's inside the derivative range.
I don't know if you can do that.
How? Oh, I didn't think about that. I think the person on the right is doing King's Rule.
Whoa!
Does that actually do anything?
No.
I never thought of it like that. So I don't know if
I would
that's...
never do that. Yeah, this is very, very interesting. This is a hard one for sure.
Yeah, no, this is definitely a. I'd freak out. Actually,
Oh, yeah,
trying to find a simplifying way, but oh my god, how would you even?
I don't know.
Oh, we have a summation. That's where the sum come from. Oh, from computing the derivative. But then, how would you even generalize? I don't know.
Yeah.
I don't know. That's. Ooh. God.
Whoa! Somebody in chat said the e to the negative x squared cancels out all terms, meaning you just have to.
What? E to the negative x squared cancels out. That's ain't no way. Ain't no way.
All you need to find is the x to the 20. Wow.
No, ain't no way.
Wow, that is ridiculous.
Someone find that term. Oh no. Oh my god. Oh, okay. Actually, you know what? I think I see how this goes. Thank you, Vengeance. So
Yeah, right.
the e to the x squared, turn that into a Maclaurin series. It's one of those Maclaurin series problems where it's like you turn it into a Maclaurin series and you find the nth derivative of that Maclaurin series, and then finding the term of that.
Term go away.
Yes.
Wow, that's cool.
Oh my god.
Then you end up with like a series. Oh wow, that's super cool.
Yeah,
Yeah,
and
but
they're not gonna have enough time. There's no way. Square root of pi. Oh god. Wow.
Whoa, I don't know what this answer. Oh, it looks like. Yeah, there's no shot. That's crazy.
There's no shot. Yeah.
So yeah, it looks like you get 2025 2 x squared terms, and then the 2025 factorial just comes from computing the for power rule. Wow.
Jesus Christ.
That's crazy.
That is really crazy.
That's a wicked small finals problem. Holy moly.
That was brutal. That was a really brutal integral.
We need to get some of the guys from chat up to Austria. That's what I'm thinking.
Man. Alright, next integral.
3, 2, 1, integrate.
Oh my god.
This is ridiculous.
Excuse me. What in the floors are we looking at?
This is gross, dude.
Any, God.
A lot of the, off first rip, a lot of the terms go away.
Oh, do they really?
I mean, yeah, just based on looking at it, all the terms after maybe pi over 4, they go away, which will be most of them. Or maybe pi over... But I know most of the terms go away because at a certain point, everything below pi at a certain level is 0.
Mm-hmm.
And same thing with cosine. So you might need to split it into 2 different integrals and find them end up going, like, what number they both 0.
Oh,
definitely
okay.
a lot of them go away. They are also both even functions, so...
Yeah, I just noticed that too. That that's an even function, so you could just go from 0 to 2025.
But where it equals 1...
Yeah, I'm trying to find that where it equals to 1. 0? Oh, okay.
We have an
I
answer.
don't think that's right.
Yeah, no. Yeah, no, I don't blame him. Like,
No, yeah.
if you don't know
Not
where to
even-
start or not even knowing how, there's no point.
Ugh.
But I think William She's trying to.
2 minutes left.
Small graph.
I rock with it. Can't even blame him.
Oh god. The floor of 1 plus inside the trig function. That is just evil.
Yeah.
The floor of 1 plus x squared inside sine square and cosine square. Inside a floor function.
So gross.
Oh
Well,
my god.
okay, so sine from...
Oh! 2 root 2?
Oh, that is
What? What? What?
He's a genius!
That's
William T.
crazy.
Oh my god!
Wait,
What in the
How did
world?
he figure that out?
I mean, it's literally you just look at where sine and sine are, because like what values of pi is sine squared and sine graded. That's all it is. And then you
Really?
just need to solve where x is equal to that, and then it's gonna turn into that number from 0 to that number of times the 1 or times 2. So it
Oh,
looks like from
Jesus.
0 to root 2, because pi over 3. If you plug in root 2 to the functions, you get pi over 3. And then sine and cosine, they'll both be above 1 at that point. So they both round down to 1. And then multiply by 2. Because you get sine and cosine.
Hmm.
Oh,
Oh
awesome.
no.
Yeah, this is terrible. This is a despicable
Oh
small fucking-
no.
This is gross.
Oh no.
Yeah. They're gonna need to do some use some of that IMO algebra.
Yeah, I would cry. I would
Yeah.
honestly cry.
That's a reasonable thing to do here. I can't lie. It's not a bad call.
Not a bad call. Well, I would say, yeah, you'd probably have to speed bash it. I think that's what both of them are doing right now. They're speed bashing it. Recognize that the denominator is factorable, the factors, and oh, what? Arctan? Wait, what? Whoa. What's going on in the right side?
Yeah, I'm not sure. I think, if anything, I'm looking at what he's doing, I think there needs to be a root. I don't think it's just... Yeah, I don't think it's... I think he's missing a couple terms there.
Okay. God, the fact that it's an indefinite integral makes it so much nastier.
So much more. So much.
Yeah, because then you can't do a shortcut. You have to actually find the antiderivative.
Yeah.
And I don't think the antiderivative is going to be pretty.
No, not at all.
Oh god. Both of them are really grinding it, just trying to
Yeah.
decompose
I
it.
think that's the best way to go about this one, is to just get moving as soon as you can, because you're
Yeah.
gonna need every single on these partial fractions ones.
Oh my god, I would not do partial fractions. I would try doing the square technique. Just kind of complete the square, u subbing
Yeah,
u minus 1 over x or x plus 1 over x, something. Time to what? Time to guess?
Minute left. Oof. Well, it looks like they're both
no.
getting close to any sort of antiderivative here. I'm seeing an ln absolute value on the.
Oh god.
Yeah, this is rough. Oh, it looks like you might be writing out something on the right.
Oh. Less than 30 seconds left. Whew. Oh no, 10 seconds left.
Oof.
God.
Yeah, we might not end up with an answer here. Oh! Ooh, disgusting.
Oh my god.
Yeah, that's just terrible. That's just terrible.
Yeah, that I figured. That looks like something you would use for a square technique.
Oh
Yeah.
gosh, that's just so gross, dude.
Yeah, the denominator factors, but you still have to do you either partial fraction or square technique. But either both ways, they're gonna be very tedious.
Yeah.
God. Yeah, that is. Look at that. That answer will always be in my nightmares.
Yeah,
oh god.
Just.
Oh, you're breaking up. Whoa.
Oh, sorry.
Your mic. Oh, there you go. You're back. Yep, you're back.
Yeah, that problem is absolutely disgusting. Oh, next one.
Here we go. Oh my god. Oh, come on.
Yeah, see, they're right there.
This is come on. It's a very famous integral. Oh, this one person factored it.
Oof.
Oh my god! Ah!
Oh my god!
Oh no! See, this is why it's so important to recognize your integrals. You know, especially doing as much past integration bee problems. You get recognition, and you start to recognize some famous integrals or reoccurring integrals, and this is one of them.
This one pops up literally everywhere.
Yeah.
You gotta be able to recognize these ones where it's any sort of polynomial over log. You're gonna see them a lot.
Man. How many of you guys in the chat remembers Feynman integral? Oh, actually, the person on the left seems to be putting it in a Fulani format. That actually might. Oh.
See here.
But it's all in the matter of if they notice, or if they even know what a Fulani integral is.
Yeah, right.
But man.
But it looks like on the right they're trying to generalize in terms of alpha, so they have to solve a 1 integral. But it looks like they've kind of stumped themselves there.
Hmm. It looks like the person on the right. Did they do Feynman technique? That looks like x to the power of a.
But I think they're doing that to general.
Okay.
Do Feynmans, which is unfortunate because they really are right there.
Yeah. One might be doing Feynman, one might be doing Fulani. But
yeah, right.
Both have to recognize those integrals.
Yeah, because that would be huge for them, right? Either one. That's a big momentum shift.
Yeah. Oh my god. Oh, they're just right there. Oh my god.
No.
They're just
Crazy.
right there. Just right there. Oh my god.
Do an integration by parts, it seems on the right.
Kumich is very, very close.
Mm-hmm. I think without doing some non-elementary technique, I think I'd be able, which is unfortunate. But they're gonna have to pull something out here in these last 30 seconds.
Oh no. 15 seconds left. I think they're both stuck.
Yeah, this is bad.
Oh.
Dang.
Dang, yeah. No. Out of time.
Oh, nope.
Damn.
Out of time.
Yeah.
Wow. Unfortunate.
Oh.
He has.
Alright, well that concludes our third place match. Yeah. Man.
Yeah, Chi comes out with it.
That 1 pointer.
Yeah, right? It really all does come.
Alright. I think they're gonna have a 10-minute break.
But yeah, so Max did his bachelor's thesis on the ELO of the integrals, of the integrators, and
he sent me a pro.
Oh, wait. Evan? Oh, let me... I can barely hear you. Your mic went somewhere.
Hello?
Hello? Oh, I could barely hear you. You're like very low.
What happened to me?
I don't know. Your mic went like completely soft.
Can you hear me?
Hello?
Hello?
Yeah, I can hear you.
Okay, nice.
Oh, you're still very soft though. Like,
Oh, no.
yeah.
Alright, let's see if I can. Let's see if I can figure something out here. Why that's happening.
Yeah, to the viewers, 10-minute break. If you need to use restroom, go ahead and use it right now before you miss the final round, the most intense part of this Integration Bee in Austria. Oh, we're being taken away.
Here we have our
Hello,
finalists.
can you hear me?
Gabriel, how do you feel?
Oh, I hear you.
I'm quite excited. I mean,
Okay, perfect. Am I
We're
live
being-
yet?
Dominic, so it's
Inter-
not a real feud, but I'm just enjoying.
Okay. What do you think about the integrals?
So far, they were really cool. I really enjoyed them from this day and also from yesterday. Although I think like this day is a bit more easy than the last.
Easy.
Maybe.
Easy than yesterday.
I mean, maybe you realize that you're not that good in integrating and you decrease the difficulty.
We didn't change the integrals between yesterday and today.
No, but I don't know. It's rarely in math that you get to do a competition which has live audience.
Yeah.
it's a different feeling. There's a different big twist.
Yeah. Okay. Well, good luck in the final.
Thank you.
You know, definitely a different feeling, especially in Integration Bee environment. Oh, and then we're back to our position. Evan, are you still there? Evan?
Yes, hello, can you hear me?
Okay, I can hear you, yeah. Your mic just sounds different. I don't know what happened.
Oh,
Yeah.
I'm also not sure what happened. Here, can you hear me now?
Yeah, I can hear you.
Okay. Yeah, I'm not sure, honestly.
It just sounds different. Completely different quality.
Better or worse?
Worse, to be honest.
Okay.
Yeah. It sounds like
Well, that's,
it sounds like your mic has moved to like from phone or mobile.
No, I'm still on my laptop.
Okay. Huh.
Yeah, that's why I'm not sure.
Pull up the bracket again. Our finalists: Dominic Potard and George Flugo.
But yeah, these two finalists, I with the ELO ranking are actually
Oh no, you're
Dominic
wait.
actually. Oh,
Hello,
can you hear
Evan?
me?
Oh yeah, I can hear you now.
Hello?
I don't know why your mic is like cutting off. It's like cutting off here
Oh
and
my
there.
gosh,
Yeah.
that's terrible. I have a Dominic has a 75% chance based on his previous performance.
Oh dang.
So, to be fair, that does not account for any practice. So, well, it's really still is anyway. But just based off the last two integration bees, but it's funny because based on their ratings on the website, this is actually our.
This is actually our what? Wait, you got cut off there. You got cut off
Oh, no.
again? Your mic is your. You want to try rejoining, like leaving it and then join back and see if it's if Discord. Hello.
Hello?
Oh no, it still sounds the same thing.
Oh my gosh.
Yeah.
Oof. I wonder why. Here, 1 second. Let me leave real fast. See if I
Okay.
can't fix it. Okay.
Yeah. But yeah, if you check out the website in the Austria Integration Bee, we do have an ELO system. We're speed integrators. It's amazing.
Here we have our second finalist, Dominic. How do you feel?
Yeah, I feel great. I'm having lots of fun.
Are you nervous?
Yeah.
Yeah. Gabriel said it's more like a friendly match because you two are good friends.
Yes, we are.
How did you like the integral so far?
Well, I think I really like this.
What about compared to yesterday? Gabriel suggested that today they are easier.
Today I think the integrals were kind of on the easier side, but at the final there are other integrals, right?
Yes, of course. Okay, well, good luck in the final.
Thank you.
Oh, I think we're about to start finals round. Oh no, Evan! Evan! Evan, come back!
Alright, I'm back. Can you hear me?
Yeah, I can hear you.
Okay, nice. Awesome.
I was just gonna be. I literally just said like Evan, come back, and then you joined as soon after.
You summoned me. You summoned me.
Oh my god, the summoning was great timing.
That's funny. But yeah, well, I was saying that based on our rankings on the website, this is actually our first and second highest ranked people are our finalists today.
Oh wow.
Which is yeah.
Oh, that's gonna be crazy.
No. So I mean, hey, I guess the ELO ratings work. They're very accurate,
boy.
it seems. Whew, I'm very excited.
Me too. I think they're just getting set up right now. I think they're about to start the finals round. I'm on my seat. I'm tense.
I know, me too. This is nerve-wracking for sure.
And then to all you viewers out there too. Oh man. Oh. Okay, I just want to make sure. Oh no, I'm trying to find the pit. Oh, actually no. Never mind.
The rankings or whatever.
Oh no, I was just I was going to the Integration Bee website.
Oh, I see.
Yeah. And they're getting set up right now.
Mm-hmm. This will be very exciting. I'm on the edge of my seat.
Oh boy. Here we go.
Yeah, I am absolutely thrilled to see who comes out on top here today.
Yeah.
This should be a wild time for sure.
Oh boy.
Okay, are you ready?
Yeah.
Okay, looks like we're getting started.
And you can wait do you like this event enough that you want it to become like a semestrial tradition?
Yeah, that's what I like to hear!
Yes, yes, we do. Please.
Some of you who know us know, some of you don't. Two of the people who started this event will no longer be in Vienna after this semester because they finished here. So the team is getting kind of a bit slimmer. Now, if you like this event and you want it to continue, we invite all of you with whatever you want to help or whatever role you want to have to contact us right now after the event or over the summer. And together with the remaining of the team and with the new guys who joined, we are going to construct this new team that wants to take Integration Bee Vienna further, maybe without the mistakes we have done, maybe to bigger audience. We need people who can do social media, people who can do integrals, people who can do logistics, a lot of people with a lot of skills. So if any one of you is interested enough in this event to want to get involved, to have a role, to make sure that this event keeps going every semester, maybe to bigger audiences, maybe with better integrals, who knows, then I would invite you all to help us. Is anyone here just like, I don't know, just so that we can get an idea, interested in getting involved in this?
For sure.
Raise your hand if you are.
Yeah, for sure.
Yeah!
Otherwise, there is a big probability that the match you're going to see next is the last ever match in Integration Bee Vienna. So if you don't want that to be the case, please get involved if you love this event. We welcome any of you with whatever skills you have. We just need you to love the event and that's it. Thank you.
Yeah, woohoo!
Now you have all, or maybe not all, some of you have seen the poll that I told about, some of you have voted, and I can see right now 19 responses. So let me show you the responses.
What's gonna happen? It's a little blurry. Just a little bit blurry.
A very important thing to note is that there is perfect equality between the two actual finalists. That makes it even more exciting. So,
And I wanted to tell you a little insight from our side. We can't go against the majority. So actually disqualify everyone.
oh, the majority voted for a winner, so we can't disqualify them.
Yeah,
That's crazy.
I want to see the final. Do you want to see the final?
The majority voted that both are going to be disqualified. That's hilarious.
It seems as though the hex worked. The disqualification hex.
Oh my god.
There they are.
There they both are.
The final obviously is also most out of 5, but because the integrals are maybe even a bit more.
Oh, this is exciting. This is exciting. This is going to be a lively matchup for these guys. And they do have 5 minutes for each of these problems as well. This is important to know. Important to know.
Oh my god. That's a lot of logs there. From 0 to 1. Oh. Oh, they're just simply just writing it out.
They're right into it.
Yeah, but right here.
This is one of my problems. I thought this was an interesting one.
I think the first thing I would do is let u equal ln of x. And then
Yeah, I think that's a good plan.
it seems to be like reverse product rule.
That is kind of the vibe here. That's what you're trying to get out of this.
Gotcha.
I try to make it look as much like reverse product rule as I could.
Ooh. X equal e to the u. Okay. Oh, I didn't see that e to the u though. Oh crap, I didn't see that coming.
I know.
E to the u. Dang.
Yeah, this is an interesting one for sure. This definitely will test their ability to perform some just basic integration, just in the right order, just with the right mindset going into it.
Uh-huh. Well, you know what to do, chat. Laplace. That's what I would have done. I just used Laplace transform.
Laplace definitely is not a bad call here. That is doable for sure.
Yeah.
But there is a very fast way to go about this one, which is basically you notice the fact that all you're missing for it to be a reverse quotient rule is an x in the bottom. If you just have an x times that log squared, it becomes a reverse quotient rule. And then you're able to get...
Dang.
If you do integration by parts on x for your derivative, and then you integrate into the reverse quotient rule after multiplying by x over x, and then you get an integral that's sine of ln divided by ln, and then that's just a Dirichlet integral after you do some u sub.
Oh my god.
Yeah, and then that's like the fastest way to solve this one. For
the person on the left did integration by parts, it seems, and got something. Oh my god, that actually might look correct.
Yeah, I think
that's actually at the right. Yeah. Oh my god. They're both writing fast and writing big.
Yeah, they're both flying through this one.
Jesus Christ. Oh, they're at the same position. Ooh. They're both at the same position now. 2 minutes remaining.
Oh, they're dialed.
Oh, man.
Well, looks like they're fixing the bounds on the right.
One's using Taylor series.
Yeah.
I think.
Oof.
Oh my god. I'm sorry. You guys know me very well. I would have used Laplace. I just go dive into Laplace.
So light for this.
Oh my god.
But,
it's killing me.
I did receive some insight that the Austrians don't use Laplace too much. And they don't a lot of these guys are math majors.
Oh, come on. Oh my god.
Cool.
That looks right.
I think that's it. Can't tell if it is.
Oh my god! Right. That is correct.
Wow. That was the first finals problem. That was intense. Oh my god. For sure.
From Taylor
was
series.
Scary.
That's crazy.
That is crazy solution.
Out of Taylor series.
Wow, I cannot. It looks like he just got the basic Taylor series for pi over 4. After
okay.
That is wild. That is wild that
Holy
you get that.
Hell. That was fast.
He just went. That was so fast for that algebraic manipulation of all those Taylor series.
Yeah.
To combine them all into one like that, that's crazy.
Oh my god.
Wow. Holy moly. Wow, they were both right there too.
Yeah. Alright, second integral. What's it gonna be?
3, 2, 1, integrate!
Alright. Oof.
Oh, Taylor series, come on.
Basic Taylor series.
Taylor series, immediately. immediately use
frame
Timmy
one.
series.
Frame one, not
There we
even
go.
close.
Ooh, Chris on the left.
Oh, he's on it. He's on it. Oh, what's he doing? He's
integration
subbing it
by
out.
parts.
Whoa.
Oh,
neither of them are using Taylor
okay.
series.
Oh no, not every integral is elementary.
Oh no, this is heartbreaking, truly.
Oh.
Yeah, this should be pi squared over 24 is the answer here.
Yeah, that's what I got.
Oh. I wonder if honestly, if they don't start retreating from the position. Oh! Look
Wait.
on the right here, we got 0 to 1 of.
That looks right.
Over.
Yeah, that's exactly what I did. Oh, that might be.
Yeah.
That's come on. Oh!
No, we need a sum. We need a sum.
No, it's not it's not an elementary integral. Come on.
No, they're doing it by parts. By parts again. Oh, on the left, they got the same thing.
Ooh, okay. Oh.
But it looks like he's trying inversion.
Inversion?
I don't think inversion will work.
Yeah, because the bounds from 0 to 1. So you won't be able to combine anything. Okay, 0. Yes.
Uh-oh. Yeah, I think you end up getting caught in a loop here.
Oh no.
Yeah, they really need to see that Taylor series is there fast. Or else they're gonna get stuck.
3 minutes left though, they have a lot of time. But...
Oh yeah, for sure.
Oh my god.
Oh no, they're gonna keep trying to U-sub it out. Well, they could pull the geometric series for it, but then at that point they need to do integration by parts again. The geometric series for 1 over x plus 1. Ugh.
Oh. Another Taylor. Oh, that actually might be. Wait. Oh, wait. Oh no, they're both.
Oh my gosh.
Half something. Person on the left is doing Taylor series. It's correct, but I don't know. I don't know if that's gonna reveal the Gauss sum. Oh, maybe.
I think. Oh, it should because after if you decompose it, you get n times n plus 1. And then you should get plus minus plus minus plus minus from that.
Yeah.
Wow.
Oh,
how interesting. God. And then the one. Oh, yeah. He's got the sum. That's the first sum we've seen on the board.
Oh, come on.
Just over a minute. I think this is doable. If he could get 2-0 right here, right off the bat, that'd be huge.
Yeah.
A minute
5
left.
or 6. Oh, come on. Be very careful. Ooh.
Oh, you see the constants here. You see the constants.
There's a constant.
You're
oh, no! Oh!
No!
Oh my god. 45 seconds left. Now it's all up to Lugo.
I can't believe it! He was so close! He just missed a couple of constants, man!
Yeah.
Oh, that blows. You hate to see it. You hate to see it.
Oh my god. Now see if on the right figures it out.
It seems like they've been stuck in the same cycle. Just going back and forth.
Yeah. 10 seconds. Zero, no. Yeah. High score over 24. Oh my god.
Wow. Wow, 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 wow. Alright, we're moving on in 3. Holy moly. That was a roller coaster. That was a roller coaster.
Yeah.
Yeah, that'll get your heart pumping. Holy moly. I'm surprised that they've been using Taylor series very liberally throughout this whole thing. I'm very surprised they didn't see that straight
really
away.
have been. I can't do it like that. Like I have to do it like like a sum.
Yeah, me too.
Here we have what?
This is one of mine. This one is evil. I found 3 different ways of solving this one, and none of them are pretty at all. They're very cool
really?
solutions, but they're hard.
Oh shit.
One of them is very tedious, and 2 of them are quick, but very, very hard to see.
Dang. I was
It looks
thinking,
like currently.
I was thinking that like you might use like Glass's master theorem.
That is one of the ways. This is definitely solvable through classers.
Oh my god.
Another sneaky way is inversion. This is solvable through inversion. And then it looks like on the left here we've picked the third option, which is partial fraction hell.
God, I think that's what the person on the left is doing right now.
Yeah, so they're gonna end up with I think 5 different linear equations. So
oh my.
yeah, they have F all the way up to F is that constant. So this is doable, 100% doable, and especially in the 5-minute time frame, I think it's reasonable to solve for that if you're confident in your algebra abilities, which I bet he is. So.
Oh.
It looks like on the right we're going through
trig substitution.
Trig sub, which I have not seen. It might be possible, but I have not seen it done. This is a hard one for sure.
Yeah. Oh god, and that trig integral is nasty as well.
Yeah, that is gross.
God. Oh no, you can't do that. Wait, you can't let x equal to a sign. I just realized because your the bounds are negative infinity to infinity. Yeah.
So I wonder what they're gonna do here.
Oh no.
Yeah, this might be rough.
Okay. Huh.
I feel like they're trying to simplify it.
Yeah. Try to find some sort of cancellation.
Uh-huh.
Yeah, oh my god.
And if you do inversion here, you actually, if you add 2 kinds of the same integral, you get like a very, very basic one after simplifying. You actually end up getting just from negative infinity to infinity of 1 over 1 plus x squared.
Oh wow.
So yeah, so you end up being able to cancel out the 1 plus x to the 4th. So somebody in chat actually called it that this does all just come out to pi over 2.
Oh my god.
So Zer07 in chat literally called that it just comes out to pi over 2 after inversion, which is wild.
I bet you $5. I bet you $5. Someone is going to like at last second. Someone's going to guess pi over 2.
Yeah, that would be crazy. That would be crazy.
If I get that right, y'all better subscribe to the Austria Integration Bee.
Yeah. Yeah, everyone needs to subscribe right now.
Oh my god.
A minute left.
Wait, I see pie.
I do. Uh-oh. They do have that plus pi over 2 right there. So I'll be
Yeah.
interested to see what they end up doing with that. About 30 seconds left. They're running low on time here. I know. On the right, it seems like they just stuck with the trig.
Yeah, that trig is. Oh god.
It's too nasty to simplify, and your bounds are
that's a
just
horrible face. It's a horrible face.
Yeah. Ugh.
15 seconds. 10.
Oh,
Oh my god. Come on.
circle something.
Guess
Just circle
something,
pi
guess
over
something.
2.
Oh my god. I'm just waiting for it. Circle pi over 2. Oh no! Oh my god! Oh wait, did he got it? Oh wait, no, he did got it. Yeah, he did got it.
No.
Yeah, it was I equal pi over 2. Oh my god, I guessed it right! I told you guys! Last second, I equal pi over 2. Oh, y'all gotta subscribe now.
That's crazy!
I knew it! I knew someone's gonna guess pi over 2 last second.
Called it!
Oh my god, y'all better subscribe now.
Everyone has to subscribe.
Damn, that's 2 points now.
2-0. Holy moly.
Oh man.
Dang, that's crazy.
Ooh. Oh man.
That's wild. That is wild. You can do Glasser's master theorem for those in chat by you can break up x. You get 1 plus x squared times 1 plus x to the 4th, and if you just take out the x to the 4th, or this is after you do inversion, you can get to x to the 4th plus 1 over x to the 4th, which you can factor, and you can end up getting. You have to do completing the square twice on it though. Until you're able to get to something that you can turn from Glasser's.
I believe.
Holy dude, that was.
Daniel doesn't solve this one, then Dominic totally do it. And then there was 3 integrals. And with 1 left and 2-0, nothing can happen.
Alright, next integral.
Next one.
Oh! A limit
Nasty
integral.
limit. Holy moly.
Oh boy. Chat.
Down to the top is sign of 1. Oh!
What?
Guess 0?
0?
Why?
Oh no!
Why did you do that?
Vienna is a winner.
Damn.
Oh my gosh! What?
Wait.
No!
Oh.
You just gave it to me. Wow. Great job. Dang, man. Wow. I bet if he hadn't done that, I bet they would have been able to work it out. Holy moly, man. I don't know why I feel like it's weird that they're stopping here.
No, they are stopping it here.
I know. Why? I feel like there's still a chance, right? I mean,
I
he
thought
only
there
has 2,
was,
not 3.
yeah, but I think they just gave it to.
I guess so.
Okay, we have 2 things left. First, the closing speech, and then the award ceremony.
Are they closing because of time?
Everyone, even from day 1.
Oh, maybe. Yeah, it might be done at like 1
Oh, they're
or
rushing
something
it.
here in 3.
Okay.
Dang.
I was gonna. I wanted to see if he was gonna be able to figure it out, but.
I know. That would have been crazy.
Oh, why? Why did he guess 0?
Dang, bro, that's.
What?
Oh, these are all fun ones. Come on, guys.
I'm contacting Max. What happened? Actually.
Yeah. Yeah, that'd be great.
I don't know if that was intentional or if that was
forced.
So guys,
Wow.
we are over. That was the Integration Bee Spring Edition 2025. I remind you that we have social media, Instagram and YouTube. We have other stuff, but it's less important. Please subscribe to those because we post mostly there. And if you want to keep updated, see stuff there. And on Instagram, you can find the recording of the stream that is currently being. Well, on YouTube, you can find the recording of the stream as it's happening right now, and to stay there forever. It's history. Yeah, and if you post something about Integration Bee, please use this hashtag. That would be really cool. We have some photos on Instagram or on X or Twitter. So let's remind you who we are. This is the number of the guys who are responsible for this everything. Team members, more team members, and yeah. Again, special thanks to Teresa Eisenberg for helping us organize this event. That is very important that she helped us. And Senovina for helping around here, doing and managing some stuff here, drinks and everything. Our future plans. So Sam already told you that some of members of the organizing team might be leaving. Some of them are leaving. Some of them might be leaving. We'll see. So as we already told you, we need some new team members. That would be cool with new ideas. So we expand and come up with new ideas. We will work more on games on the website. So far we have the integral gym, but we already have a few more ideas how to expand with it. We also are looking into possibilities to make an event a bit bigger to involve not only maybe Uni, maybe something else, like the Uni or something, because since the event is happening mostly at the Uni, almost nobody from the Uni is coming, and that would be nice to have it partially there. Yeah, and we have lots of more ideas, so follow us and also send us your ideas and we'll implement them. Now, let's have the ceremony with prizes. I will award the diplomas to everybody and also give the prizes. So I call the stage, first 8 finalists, Joseph Lesnar.
Yeah.
Third participation out of 3.
Second 8 finalist is Jan Wollreich. I really hope we have all 8 finalists. Thank you for participating. Okay, the next 8 finalists is Pablo Shaket. Are you here?
Someone come in front of him.
Yeah, taking certificate.
I generally love that you get awarded for participating.
Thank you for the participation.
Yeah, that's definitely lit.
Next 8 finalists I'm going to announce is. Yeah, I'm just not sure. No, it's quarterfinal. Sorry, we have a typo here. Yeah, so I'm just saying the text one. So we go to quarterfinal. Bruno Steinmetz. Now, unexpected member of our quarterfinals, Moshe Kopper. Really like your initiative that you wanted to participate last time. The last moment was Next, one quarterfinalist I want to announce was Denise Busti. And now we can move to the small that happened today. Severin Homish. And little surprise.
Money, a lot of money.
So, yes.
Right, read the title.
Yeah. What?
Erwin Schrödinger, was ist Leben? Die lebende Zelle mit den Augen des Physikers betrachtet.
Now we get to the quarterfinals. Alexandra Serikova. Okay, now we're moving to the third place. William Shi.
Oh my god.
Yeah. Now our reserve second place, Gabriel Krugler. He received a larger book.
Die Stunde der Physiker, Einstein vor Heisenberg und das ging das.
And the winner, the guy some people were cheering for, and finally know him, Dominic Bulldog!
Two-timing winner, actually.
The goat. The goat.
Egg jar of honey. You receive custom trophy made with help of our sponsor Kagama. Look at this. It was 3D printed, especially for him.
What? Jesus Christ. Oh my god. Yeah, we can see it on the stream. Sheesh!
This prize is coming from our great sponsor, SmartKiss. That is a Viennese company doing lots of stuff in accounting and in IT consulting. And from them, you receive this great PS5 sling. Just enjoy the prize.
Alright, they're just gonna do photos. Yeah, I didn't want to interrupt the entire presentation, but for those who didn't know what happened, so it was coming down to the fourth.
Yeah.
It was coming down to the fourth round, and if the person doesn't get it right, then it pretty much stops the entire integration bee because there was no point for the other rounds.
Ich finde, das Event macht super Spaß und ich empfehle euch auch teilzunehmen. Unbedingt. Macht super Spaß.